Hey everyone, today we're talking about assignment 62. This is going to be more about connecting f prime with f double prime and f. And I kind of want to start with this fill-in worksheet. It's called 62 in class, it's fill-ins. And the first statement is if f is increasing, then f prime is what? If f is increasing, what's true about f prime? That's right, f prime is positive. Or you could have written greater than 0. The slopes on f must be positive for f to be increasing. So the slopes of f positive. Okay, 2. F prime is negative if f is doing what? That's right, f must be decreasing. F is decreasing to make f prime negative. F double prime is positive if f is, well, f double prime positive. Oh, you could say f prime increasing, but this is asking about f. F double prime positive means f is concave up. Number 4, f double prime is negative if f prime is, remember, these are the slopes of f prime. The slopes of f prime are negative numbers, which means that f prime slopes are negative, and so we want to say decreasing. Number 5, if f is concave down, then f prime is, well, I know if f is concave down, then f double prime must be negative. And if f double prime is negative, we know that f prime must be decreasing. Huh, that's just another way of asking the same question. And you have to be comfortable with all of them. So let's build some more comfort. Okay, if f prime is decreasing, then f is what? F prime is decreasing. F prime decreasing. That's going to mean f double prime is less than 0. And if f double prime is less than 0, then f is concave down. Okay, what's next? 8. If f prime at a point equals 0 and f double prime at that point is less than 0, then f has a at x equals a. Well, what do we know? We know we have a 0 slope on f, and we know that f is concave down at x equals a. Concave down with a 0 slope, f has a max at x equals a. Okay, what's next? 9. If the slope of f prime at a increases, then f is what? The slopes of f prime, that's going to be f prime of x. The slopes of f prime are increasing. So I have a slope of 1, I have a slope of 2, I have a slope of 3 on f prime. So slope of f prime are increasing. Well, the slope of f prime, I could erase all of that and say f double prime is increasing. Yeah, I don't know anything about that. I'm looking at this problem now as though it's more than a typo. The slope of f prime, that's f double prime. F double prime increasing? No. F double prime positive or negative, but not f double prime. No. Sorry, skip 9. I'm going to have to edit that one. You know, I think I do have made all these edits by now, but clearly no. And maybe actually you're doing the one that has been edited and wondering why I'm getting stuck. Okay, f has an inflection point at a, then f prime has a max or min. And f double prime is 0. Yeah, because on f prime, if I'm going like this, so here's my f prime graph. These are 0 slopes on f prime. So on f double prime, they would be zeros, positive, negative, positive. So here's my f double prime graph. I see 0, and I see positive, and then negative, or negative, then positive. So I have the sign change on f double prime, which means f has inflection points. But do notice this one. Maxes and mins on f prime will be likely these inflection points on f. Okay. 11. If the slope of f prime is negative, then f double prime is negative. Because when I see the words slope of f prime, well, that's just f double prime. So if the slope of f prime is negative, then f double prime is negative. Okay. 12. If f has a horizontal tangent, then f prime at a is 0. F prime of a is 0 if f has a horizontal tangent at x equals a. 13. F prime of a equals 0, then f has a, no, it's not max or min. It's horizontal tangent at x equals a. And what about horizontal tangent? Well, think about it. Let's see if I can draw. Oh, we'll just do it from a sign chart. There's sign chart, f prime, a, negative, negative. Well, do I have a max or a min? F prime at a is 0, but negative, 0, negative. So that's just a horizontal tangent. You know, think about y equals x to the third. We've got that horizontal tangent there. I'm increasing, 0 slope, increasing. No max or min. So I can't speak to max or minness just because f prime is equal to 0. But I can say there's a horizontal tangent there. Okay, 14. If f prime has a change in sign and is always defined, then x has either f of x has either a max or a min there. Yes, because now that we have that change of sign, we know we either have a max or a min at a. Okay, 15. If f has a cusp at x equals a, cusp at x equals a, x equals a. So here's f, here's the cusp at x equals a, then f prime at, well, come on, f prime, okay, you can't take a derivative there. The limit of the slopes here is negative infinity, and the little limit of the slopes over here is positive infinity. Negative infinity doesn't equal positive infinity. So we say f prime of a does not exist. And if you had to give an answer or a justification, you'd say the limit as x approaches a from the negative side of f prime does not equal the limit as x approaches a from the positive side of f prime. Okay. 16. If f has a vertical tangent at x equals a, then f prime of a is undefined. You can't take a derivative where you've got a vertical tangent line. That's an undefined derivative. Okay, next. Sketch a curve whose first and second derivatives are everywhere negative. F prime is negative, f double prime is negative. Well, f prime negative means f is decreasing. F double prime negative means F is concave down. So I want decreasing and concave down. Okay, that's A. B. Sketch the curve whose first derivative is positive and whose second derivative is negative. So again, F is concave down, but now F prime is positive, so F must be increasing. I want increasing and concave down. Okay. C. First derivative negative, second derivative positive. F prime less than 0, F double prime greater than 0. Well, F prime less than 0 means that F is decreasing, and F double prime greater than 0 means F is concave up. Decreasing and concave up. And finally, D, first and second derivatives are both positive. F prime greater than 0, F double prime greater than 0. So I want F increasing, and I want F concave up. There we go. Those are our 4 shapes, and we've been talking about those for a while now. Okie doke. 18. 18 says, sketch a smooth curve whose slope is both negative and increasing. Slope negative means F prime is less than 0. Slope increasing means F double prime greater than 0. Okay, again, the slope is both negative and increasing. Okay, so I know F prime is negative, but I also know F prime is increasing. F prime increasing. Well, F prime increasing means F double prime greater than 0. So I'm supposed to sketch a graph where F prime is negative and F double prime is positive. So I want F to be decreasing and concave up. There we go. Oh, but later, negative and decreasing. So it starts off this way, but then F prime continues to be negative, but now F double prime is less than 0. There we go. So starts off this way, then becomes this. Okay. B, sketch the first derivative of this. Okay. So first derivative of this, well, since F prime is always negative, my F prime graph has to be down here. And since I'm, I think I have a 0 slope there. And then what can we say? We know F prime is increasing. F prime is increasing. We get to a 0 slope, and then F prime is decreasing. I don't like that. There we go. I think that's it. No, because that's, I got concave down, I got concave up. This is F prime. This is F prime. F prime is F. No, we're looking. Oh, that's F. This is F. This is F prime. Okay. Negative, negative, negative. Yes, yes, yes. Concave up means F prime is increasing. Concave down, F prime is decreasing. Good. Whew. All right. That was tough. Oh, wait. Sketch the second derivative. All right. So second derivative. Slopes here are positive. Very positive, less positive. 0 slope. Negative, 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 negative. So there's F double prime. Okay, so F double prime positive, concave up, F double prime negative, concave down. Yeah, I like it. Now, number 19. Yeah, will you try number 19? Really answer those questions. When is f least? When is f greatest? When is f prime least? When is f prime greatest? When is f double prime least? When is f double prime greatest? And this is a graph of f prime. That's very interesting. Okay, so we've got x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, x sub 6, and this is a graph of f prime. All right, and my recommendation is that you start with when is f prime least and when is f prime greatest. Okay. Okay, so this is the f prime graph, and I want to know when f prime is least. Well, that's here at x sub 5, that's the lowest point. And f prime greatest, well, here, but we're supposed to pick points. So on your graph, x sub 1 is the highest y value on f prime. Great. So what do you want to do next, f or f double prime? I know. I agree. F? Oh my goodness. Really? Yes, we'll be able to do it. But I think you're right. We should probably start with f double prime. So f double prime is least, f double prime greatest. Now remember that f double prime represents the slopes on f prime. So let's think about the slopes on this graph as y values here. Okay, here I have a very negative slope. And that very negative slope on f prime is going to be a negative number on f double prime, a negative y value. Well, where else do I have negative slopes? I have a negative slope here and a negative slope here. And it looks to me on our graph that this is the location of the most negative slope. This slope is more negative than the one over here. So I think f double prime is least at x sub 1. Now, if most negative slope is where f double prime is least, most negative slope on f prime, f double prime is least, what about when f double prime is greatest? Well, now we're looking for when the slopes on f are most positive. Zero slope, these are negative slopes, that's a zero slope. I guess I'm going with x sub 6. That's the place with my most positive slope on f prime. So now let's talk about f. All right, see this? This is the x-axis. And this is important in this problem because f prime is always above the x-axis. Well, what does that mean if f prime is always above the x-axis? Think about a sign chart. F prime is always above the x-axis. F prime is always positive. If f prime is always positive, then f is always increasing. Okay, f is always increasing. So if f is increasing, then the smallest f point is over here at x sub 1. F is least at x sub 1. And because f is increasing, because this f prime is always above the x-axis, then over here at x sub 6, we must have x being greatest. Because this f function is always increasing, because f is always doing that, we know the point furthest to the left is least, and the point furthest to the right is greatest. All right, well, I hope that helped. And I can't wait to see you in the next video where we practice some relating f prime to f double prime and f some more.